In front of you, you have 2 purples, you have 7 oranges, and you have 6 yellows. Make a rectangle like we did last week. So follow the rules to making the rectangle. Your big tiles, your purple tiles bottom left, and keep your yellow tiles top right. So let's see what you remember. Nicely done. Up there. You just use the tile up there. All right, nicely done, guys. Remember the rules. You have to match all side lengths, and big tiles bottom left, little tiles top right. So what you're doing is for all of these, you're trying to make a perfect section. So what we did last time is we looked at how do you make 6 units in the rectangle if they all fit into a rectangle. So now knowing this, how would you put your oranges in to make it look like a rectangle? So good, but remember those have to be bottom left by themselves. We want those bottom left and units top right. Nicely done, Tatanka. Now I want you guys to take a look at what Tatanka made here, and I'm gonna just put it so it's that direction. I'm gonna make it look, because I messed it up. You had it all nice, but I messed it up. All right, notice that this is a rectangle, and we had what was known as base times height. So let's outline that guy. And we know that we can find the area of a rectangle by taking the base times the height, or what we call the length times the width. But what we found out on Wednesday is that we don't have nice rectangles anymore, that this is like 10 and 5. This is algebra. So our rectangles have a little bit more complicated base and height. What is the base of this guy? What's its length right there? What's that length? Okay, so from here to here is x. What's from here to here? X. What about that? Okay, so it's 2x plus 3. That is our base. So what does that mean for our height? What's from here to here? X, and then we have 1 and 1, so what does that equal? That equals x plus 2. Now, that's what that's going to look like. All right, so on your paper, you all have, oh, no you don't. Don't get rid of your tiles because you're going to use them. But let's go back to what we were doing. This is exactly what we did Wednesday of last week. So I'm going to move this one. And remember how we talked about how to draw them. Okay? So you're going to draw this. And you're going to go like this, make one rectangle. And I start by cutting that rectangle into parts. So I know I'm going to have a pretty large, 2 large squares here. So I don't cut it exactly in half, maybe a little bit like that. Then I cut the top like this, I know I have 2 of those x squareds, so I just start by making, all I'm doing is partitioning. I know that my bottom 2 have to be the x squareds, and my top right have to be my units. I cannot draw each piece by itself. Okay. So we had the challenge. This was the challenge last week. Can you write the area of these rectangles as a sum and as a product? There's 2 different ways to write the area of these rectangles. So as a sum, what are you doing when you sum something? Think of your operations: add, subtract, multiply, divide. So what are you doing when you sum? Yeah, you're adding. And so we have to add all of our pieces together. Let's start with our purple pieces. We know that the area of the purple piece is x squared. How many purple pieces do we have? 2. So I'm going to write 2x squared. Now here's the sum part. Plus, how many orange tiles do I have? 7. So I'm going to add 7 orange tiles, and they have an area of x. So I have 7x tiles. And now how many yellow tiles or unit tiles do we have? 6. So I'm going to add another 6. That's one way you can write the area. Now you're going to see in your review previews, you're going to see write the area as a sum. That's what it's talking about. Now let's look at area as a product. Well, remember, product means what? Think of your operations: add, subtract, multiply, divide. Multiply. So I am taking the base times the height. So I'm going to write this one out here. So that's x plus x. I'm going to make that one clear. That's a 2x plus 3. And we decided that one was an x plus 2. So my base is 2x plus 3, and my height is x plus 2. Okay, that's what we did last week. So if you weren't here, that's what we were looking at. That was 322, and we were, if you were struggling with that review preview, come talk to myself or Mrs. O'Day, and we'll help you out. But that's what we were looking at. Okay, but now today, you know Algebra 1, you always are going to make things just a little bit more challenging. So today the question is, can you work backwards? Remember, last week I gave you this. I told you, you have 2 purple tiles, you have 7 orange tiles, and you have 6 yellow tiles. Go. And you had to build it. But today, I'm going to give you this. So how is it you're going to work backwards? Well, let's try one. All right. Here is the area as a product. All right. So this is where things get just a little bit more complicated. Because now we don't know how many pieces we have, but I know how big that side is. So I want you guys to think about this. I want you to look at the base. The base is 2x plus 1. So let's see if we can draw that. Or actually get your tiles out. Get your tiles out and let's see if we can build this. What do I have right here as my base? If I just had 2 of those, what do I have right here? I have 2x, but do I have 2x? No, I have 2x plus 1. So I'm gonna have to do what? Can I do this? Is this legal? No, it's not legal. So what color tile do I have to put right there? Yeah, good, Keelan, I have to put in an orange there because that's the rule. I have to match sides. So does that work? I have 2x plus 1. All right, so that's done. All right, what do you notice, Jacob? What do you want to add on the top there? So you have yours a little bit flipped for fun. But that's okay. Okay. All right. What is the height? So I'm going to move this down a little bit so I can fill this up. The height is x plus 5. What do I have right now? I just have an x.
My height is just x right now, okay? So right now, I have x. But I need a +5 up here. So what can I do? Just think about the way you've built these, okay? Think about the way you built these. So if I do that, remember, I have to keep my perfect rectangle. Do I have x + 5 right now? What do I have? X + 1. So what do I have to keep doing? I've got to keep adding until I get to 5. So what do I have? Am I done? No. Got 2 more to go because I only have x + 3 right now. So I have to do this. I've got to do that. Okay. 1, 2, 3, 4, 5. Woo! There it is. So that's how you work backwards. You now have to fill in these blanks, okay? All right, now I can write it as a sum. Now I'm just asking how many total pieces do I have? But let's draw this one first, just to make sure we get this. All right, let's draw this guy first, and then we'll write it as a sum. So I have I'm gonna make mine a little bit tall here. I'm gonna make that one a little bit skinny. Got my x squared, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, if you guys look at my drawing, that is not to scale, but I want to be able to represent it in a pretty clear way, okay? So that's what it will look like. Careful about how many oranges we have. So now let's write this as a sum. Okay? How many purple tiles did we have? 2. So I have 2x squared. Okay, the big question is, how many orange tiles did we have? We had 11. So plus 11x, and then we had 5 units. Okay, I'm going to have you guys try one of these on your own. So remember, today we're working backwards. I'm not giving you those individual pieces. I am giving you the dimensions and asking you to find how many individual pieces there are. Okay, here is B. Okay, try this guy. It has a base of 2x + 1 and a height of x + 3. Can you create, first of all, can you create it? And then draw it. And then tell me what is going to be the sum area as a sum. Oh, nice.
Oh my goodness, I think we've got it. So then you're fine. That's equals 3. So now you know how to write it there. Awesome, guys. Very good. Now you write it. How many pieces do you have?
All right, nicely done, guys. You are seeing this. You're seeing that you have 2x or 2 purples. So here's where you want to check that work. Okay, this is what the picture looks like. Then you have 1, 2, 3, 4, 5, 6, 7 x's, and then 1, 2, 3 units. Now you guys are gonna watch a video this week that will help you with this kind of multiplication, because what you're doing is you're multiplying. You're taking the base times the height, and this is nice when you have the algebra tiles, but what happens when you're at home and you don't have the algebra tiles and the internet goes out and you don't have virtual algebra tiles? How do you handle this? And that's what you're gonna talk about. That's what you're gonna watch tomorrow in your virtual day. But there is also some other kind of rectangles that we can build. And so here is the first one that I want you to think about. Now, I want you to think about what this means, okay? And this is different because in my base, I just have 2x. Well, it's really 2x plus what? What is this one really saying? What would I put there if I was going to write this out like the long way? It's just 2x, but if I wanted to say 2x plus something, yeah, 2x plus 0. I can write it like that. If that helps you to see it like that, then please do so. But that's what it means. It means that you have no units attached to that base. So let's take a look at what this means. Well, I've got 2x. Do I need to put anything out here? Yeah, that's what that plus 0 means. There's nothing here. Okay, see if you can build this one. What has to happen if I need an x plus 5?
Yeah.
Very nice. You guys are seeing it. Do you have any yellow pieces in this one? No, there's no yellow pieces. And that's what that one looks like. There is your x almost. I got a little skimpy with the oranges. You have an x plus 5. Okay, I'm going to try to make that one. I'm going to try to draw it out here. All right, there it is. Okay, so let's talk as a sum. How many pieces? Well, again, remember, you don't have any yellow, so you don't have to worry about that when you write your sum. This one is just going to be 2x squared and then I have how many X's? There it is. Okay? That's what that one looks like. All right. Last challenge of these before I give you maybe a shortcut. All right, so turn your paper over. And you're going to do area as a product. So this one is going to be how are we going to handle this one? Now, this one means you have how many X's? Well, if you want to write this one out like we have been, that's the way it would look, okay, if we were going to write it out legitly. But remember, mathematicians are never going to write out the 0x. There are no X's. So when you build this, what kind of tile will be missing? Yeah, Sage, there's not going to be any purple tiles when you build this one. Okay, so I want you to think about how you're going to build this one. You have 2, and then a 3x plus 5, but there's no purple tiles. See if you can figure out how to build this one. Now I'm going to kind of flip mine for, well, I guess I can do this. How do we get a base of 2? Like how you guys are thinking about it. So I want you to think about, I'm going to make it look like this. So I know I have a base of 0 X's, but I've got a base of 2. So now I have to do a height of 1, 2, 3x, but am I done? What has to go on the very top of my lovely tower here? 5, yeah, I've got to do groups, 2 groups of 5 here. So I'm going to bring this down a little bit. So I got to keep building. I've got 5, 5. And there it is. Okay, that's what that one looks like. Now that's really hard to draw, so when I draw it, I'm gonna flip it over on its side, okay? So notice, that is 3x's plus 5. Okay. So when I draw this, I'm just gonna flip it on its side, and I'm gonna make it really long here. So I'm gonna make it tall, but I'm gonna just flip it that way. I cut that all the way down, and I knew I had 1, 2, 3 X's, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there it is. Okay. So let's take a look at how do we write this as a sum? Well, how many orange tiles did we end up with? 6. So I have a 6x. And how many yellow tiles? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do any multiplication problem like this. You can get your tiles out, you can move them around, you can build these rectangles, and you will be able to write going backwards, which is really important that you know how to do. But there is a shortcut. And I'm only going to give you the shortcut for these guys. So for question C and question D, those are kind of nice. When we give you these shortcuts, you never, okay, have to use them. If you prefer to build the tiles and get them, that's great, because I will tell you there's sometimes the shortcut when students try it and they get it wrong, and they would have gotten it right if they had just drawn it out. So just be careful. So let's go back to problem C. So problem C was this. I took 2x times x plus 5. So I'm going to have you write that out again. Now I want you to look at what the answer was. And I'm going to put the answer up here so you guys can see it. You see that it was a 2x plus 10x? Where do you think the 10x comes from? Just look at the numbers. You don't have to draw out the rectangle, but where does that 10 come from? Good, Keelan, 2 times 5. And here's what I want you to see. This is known as distribution. You can distribute that 2x to everything. Okay? You can now take 2x times x. Oh, thank goodness we know exponents, because what's x times x? 2x squared. So I have 2x squared, and now I take 2x times 5, which is 10x. Oh, that's kind of handy. I don't have to draw out all those rectangles. You don't. But I want you to show you where those rectangles come from. All right, let's try D now. I'm going to just have you rewrite it. That's the one that you just did. And let's look at the answer. We already know what the answer is, but let's use our distribution here. Well, 2 times 3x, there's our 6x, and 2 times 5 is 10. All right, let's see how you do with a few challenges. Now I'm going to throw some weird ones at you, so don't panic, okay? But I want to see how you do. I'm going to be nice on this first one. Okay. Without using tiles, how could you get this one's answer? Without using those tiles. Yes, I agree. So remember, all you are doing is you're just multiplying that 3x through. So 3 times 2 is 6. X times x is x squared. 3 times 7 is 21 times the x is 21x. And we didn't have to make any rectangles. Okay, let's do yet another challenge. Now, when you multiply this one out, you are going to get a tile that we do not have, which is okay. You actually could not do this one with tile. But knowing your pattern, I want you to think about what this would be. We thought about that one. I am, yes, asking you to think a little bit outside that box right now. Good. Okay, let's multiply this one out, and I'll give you one last one. Okay, I now have to take 4 times 2. All right, 4 times 2, no big deal. I get 8. What is x squared times x?
X cubed.
X cubed. Now, if I had written this like this, or in the warm-up, you guys would have known that. Don't be fooled just because it's not an exponent type problem. That's why we're looking at exponents. You have to know how to multiply that. So you get x cubed. Okay, let's do our next one. 4 times 5 is 20 times x squared is x squared. All right, knowing that little trick that you have to watch your powers, here is a really good one. Ooh, and I'm also throwing a y in there. That's 2 times y. How in the world do you handle y's now? Just keyboard. Yeah. Yeah. Awesome. All right, let's try this one, and then we'll talk about what's going to happen. So I have 3x to the 4th times x squared. So it's just 3 times 1. So I got my 3. Uh-oh. But what happens right here? What's x to the 4th times x squared? What do you think, Sage?
3x6.
Yeah. I have 4 x's here, and I'm going to multiply another 2. I've got 6 x's. So that'll be x to the 6th. Okay? Now, 3 times 2 gives me 6, okay? So that's a plus. Remember that plus sign carries through because we're writing it as a sum. We need the plus sign. 6. Can I combine x to the 4th times y? Can I say that's x to the 4th, y to the 5th, or something like that? Okay? Remember, you're just multiplying. So it looks like that. You can't do anything with those exponents. You just multiply them together. All right, now notice, on the shortcut, I did not give you any of these. And that's the dangerous part, because students are like, oh, I'm going to do the shortcut, and it'll work out so nice, it'll be easy. Be very careful about the shortcut with those type of problems. Tomorrow, on your virtual day, you're going to watch a video for 324, and you're going to learn a different way how to handle those type of problems. It's called the generic rectangle. Make sure you watch it, because when you come to class on Wednesday, we're going to assume you got it, okay? All right, nicely done today, guys. Very nicely done. We will see you on Wednesday. Make sure you watch 324.